Hey everyone, welcome to this talk and thanks for joining Building Specialized C and C++ Tools with Eclipse Theia and CDT Cloud. My name is Philip. I work with EclipseSource, your technology partner for building custom tools, domain-specific modeling environments, or tools in general. And in the last couple of years, many of those tools have actually been in the area of embedded development and C and C++ development. So that gave us the chance, together with our customers, to drive forward many of the technologies and open source technologies that allow you to do that more efficiently and build your custom specialized tools for allowing your users to work on your embedded devices, work with your tool chains, and so on. So I'm really excited to talk about those technologies today and introduce them and even give a few live demos for a tool that I can show today that basically is available also for you as a blueprint. All right, with that, let's get started. I think since this is a TheiaCon, I don't need to introduce Theia, but let me just introduce the second technology that I list here on this slide, which is CDT Cloud. So to best explain what CDT Cloud is to look a little bit into the past. So I'm sure many of you will be familiar with Eclipse CDT, the C development tools, which have been around, I think, for more than 15 years and have been one of the most popular projects when you are looking at building a specialized custom IDE for your particular hardware with custom tool chains, with custom builders, maybe even custom language extensions of the C, C++ language family, and making it very easy to get started for your users to use those hardware tool chains, builders, and so on with project templates. So that was all really great. However, it was very much coupled to the Eclipse IDE and the rich client platform, and with that to a desktop application. So in the last couple of years, many of the tool providers and vendors were actually looking at ways to take advantage of more modern web-based UI technologies and benefit from client-server architecture technologies like the language server protocol and the modularity that comes from those modern tool architectures in IDEs and tools that we all know and love from Theia and VS Code. When you now plan to build a web-based C, C++ tool, there is, of course, a lot of technologies already available that you can have a look at. For instance, ClangD as a language server, you can still use GDB, use CMake, and of course, there is VS Code with a lot of C and C++ support, proprietary support, but there is available, and there is a couple of base technologies like HTML5, Theia, and so on that you can use. However, it is still quite challenging to find a good configuration and architecture to put all of that into one streamlined, consolidated, and customized tool. And also there is a couple of gaps when you compare the feature richness of the combination of these technologies with, for instance, CDT. So that's exactly what CDT Cloud aims to solve. Basically, CDT Cloud is an open source project at the Eclipse that aims at making it as simple as possible for building customizable web-based C and C++ tools. And it does that by providing, on the one hand side, components, open source components, which range from open source VS Code extensions, tools, frameworks, reusable UI widgets, and so on for many different aspects like providing language support, debugging, or code analysis, and more. Besides those components, however, CDT Cloud explicitly also provides best practices and templates because, as I mentioned before, it's a quite diverse ecosystem that when you're building such a tool, you need to consume tools from, and you need to put them together in the right way, configure them, integrate them into your tool. So there is a lot of best practices involved here, and CDT Cloud provides ways to let you use those best practices based on existing templates and the knowledge of the community. And last but not least, I mentioned community. CDT Cloud is also the home of many initiatives and collaborations across many stakeholders in this community that together in a very, very collaborative way address the challenges ahead when building web-based C and C++ tools. So that's the goal. What are the components in more detail? There is quite a number of components that grew over the last year quite a lot. And these components, I tried to categorize them a little bit, are in the area of, for instance, C and C++, C and C++ editing and language support. One major technology there is, of course, ClangD, which is not part of CDT Cloud, obviously, but it's still, of course, one of the main technologies that you would use when you build the C and C++ tools. So what CDT Cloud then provides in addition is, for instance, ways of better integrating them and manage them in specific use cases. So for instance, to improve the support for multiple projects within one workspace, which is not all too well supported right now in ClangD. So there is extensions of that VS Code integration of ClangD in CDT Cloud that help you better cope with this challenge, for instance. In the domain of debugging, for instance, CDT Cloud even provides an own GDB adapter, which is really focused on not just being a plain generic GDB adapter, but focused on being extensible and customizable, because that's what you very often require in specific scenarios where you build a streamlined tool. It also provides a VS Code extension to integrate it in Theia or VS Code, and even more technologies that allow you to, for instance, combine multiple debug sessions into one session so that it's easier to use for your users with the CDT amalgamator. In the area of tracing, I'm sure many of you know the great Eclipse project Trace Compass, which exists for Eclipse IDE and RCP. This has also parts that can be then used to integrate Trace Compass with all its glories and features into Theia and VS Code. And this is also hosted in CDT Cloud, since it's very useful in the embedded and C and C++ development environment. And further, there is a couple of technologies and components there that help you in the analysis, code analysis and program analysis. For instance, a memory viewer for Theia and VS Code, as well as an SVT viewer and many more. Those are the components that are available open source, but there is one more component which kind of is in a separate category, and that's CDT Cloud Blueprint. What CDT Cloud Blueprint actually is a vanilla C and C++ IDE, a generic one that you could just use for generic C and C++ development. You can actually already try it out right now online by just going to Eclipse Dev CDT-Cloud and hit the Try Online button. Then the cloud version of this CDT Cloud Blueprint will be started up just for you, and you can play with it just to try it out. Just be aware that in 30 minutes your session will be closed, because it's just there for demo purposes, so don't start a big project. Anything that you can finish within 29 minutes should be fine, though. So you can try all the components that I've listed before out, because they are integrated in this CDT Cloud Blueprint. That being said, of course, it's not just a tool that you can use. It's also supposed to be, and actually is, a template for building your own custom C and C++ IDE. So the idea is really that you take CDT Cloud Blueprint, customize it wherever you need to change it, and add your specific stuff on top. So that's probably the easiest way of getting started with your custom C and C++ IDE, because you have something up and running from the beginning, and can then start to put your customizations and specific components on top. So the idea is to get you started very quickly. And we actually put that up for a test. So in a team event that we did a couple of months or even 1 year ago in our company, we did a 5-day hackathon where we actually wanted to put in to test how easy it is to build a tool based on CDT Cloud Blueprint for a specific hardware. And as a hardware, we chose the Raspberry Pi Pico because it's easily available and very nice to use. And we just wanted to know how it feels. So that's why we all bought such a thing, which I show you here. It's already blinking. And try to build a Pico tool that allows users to get started with Pico programming as fast as possible. Of course, we only have 5 days, but yet we wanted it to be an entirely functional spike. So we were looking at topics that are very typical when you build your custom C and C++ IDE. And that's, for instance, custom project management and project configuration, allowing your users to get up and running with a project in no time, and then being directly able to edit code and flash this code onto your device, debug your device, and, for instance, have some specific hardware communication available to show, for instance, all connected devices and so on. And that's exactly what I would like to focus on in the remainder of this session. Basically go through all these things and demo it, what we've achieved, and how we actually built it, to give you an inspiration and a feeling of how this could apply to your project. So let's start with the first one, custom project configuration. So as you all know, VS Code and Eclipse Theia, both, they don't have really a notion of a project. So basically it's just files and folders, which is fine for a generic code editor or IDE platform. However, for specific tools, you very often need the notion of a project to store and collect project-specific information, make it much easier for the user to cope with multiple projects and, for instance, click on one button to build exactly this project or flash it to a device. So we wanted to introduce this notion of a project and also a project editor. So what we did actually is we've built this CDT Cloud Blueprint with this additional project support. I will show it now in the tool. So what you see here is actually this CDT Cloud Pico version, which comes, of course, with a nice getting started tutorial here on the right-hand side, which lists all the steps that you can do. And just for convenience, I will just click on this Create Pico Project button here. Now it asks me for a name. I will just call it the default name Blink and hit Enter. And with that, you see there is a README file opened and there is a few files generated. And you already see there is now one folder that is bluish, marked as a bluish folder to indicate that this is a special project. And it also tells me what this type of project is. It's a Pico project. And in addition, you see here that there is a couple of buttons that are basically actions that you can run in the context of this single project. And one button here is this Edit Pico project file. So you can click here and get a custom editor, basically, that allows you to edit all the project details and settings. Of course, you can also start actions from here, get a nice picture of the Pico here, and you can, for instance, configure where this serial printing is going to UART or USB, for instance. Whenever you change something here, it's intended basically that this will impact the respective configuration files in this project and will be picked up immediately. So that's all nice. So far, it went pretty easy. How did we actually implement that? I will try to use the same pattern for all the different customizations that we did. So the idea is that everything that is here in this color is basically something that we had to do in the course of this hackathon, specifically for this tool. The bluish items are basically components that we could just take from CDT Cloud, and the orange components are technologies that we integrated from the ecosystem, just to give you an idea. So for this project customization, we basically created a Theia extension specifically for this tool, which contains the branding, the getting started view, the file explorer customizations, and the project settings editor, and of course the specific project template that is created when you run it. Of course, this is not done from scratch because, as you all know, Theia provides many API and components that you can actually use to build something like a getting started view very quickly. And also for project templates, there is a project generator framework in CDT Cloud Blueprint that you can use to very easily generate template projects from scratch. So with that, we are already up and running. Of course, what really matters is what is being generated. And here we are actually relying a lot on CMake as a build system to basically describe how this project is built and so on. So we try to reuse as much as possible from the ecosystem, which is obviously typically the best strategy. Right, so that's basically the first step. So now we want to go to the next step, which is allowing the user to edit your project as convenient as possible. So for editing support, I can also just show that. There is one source file in here, which is already being generated. So when I open that, you see here, maybe let's close that for now. You see here, the editor opens, it has syntax highlighting and everything. That's easy. However, it's also completely already indexed and understood by the language server. So code navigation works, hovering works, and so on. And of course, all the typical things that you would expect from an editor, like code completion, validation, and so on, with errors and so on. So that all already works perfectly. How is that actually done? Basically, we are using, as we mentioned before, ClangD, but of course, maybe I'll switch back to the slides for that. But of course, ClangD needs to be configured. And in order to make this configuration happen, we are based on the specific CMake generator that we are using. in order to create the compile commands directly when the project is being created. So with that, the user can directly go and start with great language support for language editing. But we did not just do that by using VS Code ClangD integration, but we used the multi-project support so that you can, in one folder, basically have multiple projects without them having them interfered. And you can also very easily switch contexts between, for instance, build configurations that you have in your project, for instance, building for release or building for debug. Just one note here, I mentioned this before already. So VS Code, the C, C++ tools, this is not open source, right? So basically, whenever you think about creating your own tool, this is not typically an option that you can use. But the typical standard selection here is using ClangD. And if you have multiple projects, maybe multi-project ClangD could be an option for you. Right. Next, of course, we want to look into debugging. Code editing is fine, but debugging is even cooler, especially when you're dealing with embedded development. So let's have a look at how this works in the tool. So I've made a couple of changes here. Let's just all undo them and hit save. And now at any point in time, I can just click directly on this project and run debug Pico. And with that, the tool will automatically build what is currently there. As you see that running down here, and it will automatically flash it directly to the hardware that is connected, and start the debug session. So whenever I, for instance, here now set the breakpoint, then we will hit this breakpoint, and just to prove it that this is actually true, now it's getting maybe a little bit complicated. So you see here, around here, there is an LED, and I hit now continue. So now it blinked, and then it stopped blinking again, I think. So I'll put a second breakpoint now here and start just one step. So now I think it's off, and when I continue, now it's on. Now it's off, now it's on. So it's really debugging the actual hardware. And the nice thing is, of course, you can now actually really just hit stop and do some coding. I just prepared something that I could paste in here. So I will paste in here a new vector, which I will just initialize with 0 here before the while loop, and would then just in each iteration of the loop increase the value, hit save, and just do the same thing again. And now it again builds it, flashes it onto the hardware, and we are again at the breakpoint. So I continue a couple of times, and now I can look into the variables and see, my vector is here, and we passed it already 2 times. So that's really a nice developer experience, exactly what we wanted to aim for. Also, another thing that I wanted to show is the nice memory inspector that is available. So I can just, for instance, now have a look at the same vector that we just added here to the code. So now we see this is the X value, and when we continue with that, we see that this value is actually also increased in the memory directly from the hardware. So that's pretty cool. How was that actually implemented? Actually, very easy. So you see again this color here, the customization that we actually needed to do is just configuration. It's basically the generation and management of a debug configuration for a component of the CDT Cloud ecosystem, which is the CDT GDB adapter plus its VS Code extension. And of course, we benefit also from the memory view and registers view from the Theia project. From the ecosystem, essentially with that GDB adapter, we use GDB multi-arc, OpenOCD to communicate with a Pico probe. So that's this little guy here that then connects to the Pico using SWD. And with that, we can really directly debug the device. So what's really cool is that there was not a lot to do. Actually, all that is done is debug configuration management. Right. Of course, you also want to have and read serial output. So just going back to the, close this up, going back to the application, I can at any time just start, we are using Minicom here to print the serial output, and start this guy again, maybe without breakpoints this time. And now we see, cool, there is output coming. And just to prove that this is actually live, let's keep the typo in. It doesn't matter. I can just start this again. I go back to Minicom, and you see that it now prints TheiaCon. So that's cool. That was also quite easy. How is this actually done? It's just basically using the existing tooling, using the CLI, the command line interface of Minicom, and integrating that into Theia, which is super easy because you have this output channel configuration that you can do in Theia to just print anything to an output. So we communicate with this process and channel everything into this output channel. So we basically benefit from the generic Theia here, and of course from the ecosystem with Minicom. Right, and last but not least, very often you also want to have device management or any other type of very specific hardware connection. So what we wanted to do is to actually create a device manager that shows the available devices based on the Pico tool that comes with the Pico SDK, and hook this up with the Pico tool that we were just creating. So just to give you first here the architecture overview. So essentially what we did is we wrote the Theia extension that is communicating via CLI again with an own custom view to the Pico tool and query it basically for the status of all connected devices, which then, of course, internally communicates via USB with the actual or with all the connected Picos at some point. So let's see if I can also show that. And just to show you how this works, so first of all, I will just disconnect. It's pretty tough, the Pico. So now, this stopped now putting something into the serial, which is kind of expected, I guess. And now I will create open the Pico device manager. So now it says, there is no accessible devices found. I can also refresh here, still none found. Now I will, and this is a little bit fizzly, I will connect it again, and hit refresh. And here is my device now listed in the device manager, and it also shows me which flashed image there is. So just, this is also not looking very beautiful. It's also not very useful information. I'm not even sure if everything of that is actually coming from the Pico tool or is still a default value. So basically just to demonstrate that it's very, very easy to integrate basically CLI tools that typically already exist for a specific hardware into Theia and build a nice UI around it. Right. Of course, this is just a very, very short overview of what you can basically do from the Theia ecosystem, from the CDT Cloud ecosystem, and even the wider ecosystem, because also in CDT Cloud, we apply the strategy that is also done in Theia to not reinvent the wheel, but when there is something open source that we can use, better use that, strengthen that and integrate it rather than doing something in parallel. And on the same line, there is many things from the ecosystem that I just didn't mention, but which very often are very, very useful in the embedded development and C++ development area. So for instance, UIs and editing tools for hardware configuration or any configurator, data-centric things. There is frameworks available from EMF Cloud, JSON Forms, Langium, and GLSB to build graphical, textual, and form-based editors, essentially, that can deal with any sort of data structure that you can then write into a configuration file in order to configure something in the hardware or so on. And another thing that I wanted to show as a screenshot as well is the trace compass view inside of Theia. So that's also pretty cool for analyzing any shortcomings of your program on your hardware. Right. What's next? So just what I wanted to mention is also CDT, also again, CDT Cloud is not just an Eclipse project. It's really a community-driven innovation that is very, very collaboratively working on many new challenges that like-minded hardware vendors and tool providers in the embedded and C++ domain are facing. And from that, there are stemming many upcoming initiatives. So for instance, we are currently working on better support for hardware breakpoints, consistent multi-core and context debugging, SVD viewers that I mentioned before, and so on. So there is many initiatives going on. If you're interested in one of those or have even other ideas or questions, you're kindly invited to our monthly CDT Cloud project call, which is open for anyone, so anyone can just join. You can find the details on GitHub on Eclipse CDT Cloud, and basically you can just connect there. And with that, I'm already at my last slide, and I think just in time for the questions, so just maybe a few last sentences on the conclusion. So I think, or I hope I could demonstrate with that our experience with basically Theia, its ecosystem, and CDT Cloud as one important part of that ecosystem for the embedded and C++ development domain is really a great fit, because typically such custom IDEs require a lot of flexibility in terms of customization, in terms of branding, in terms of packaging it with your own SDKs and stuff like that. And that all is possible quite easily in Theia. And in CDT Cloud, there is a lot of components that you can just hook in, customize, and configure for your particular use case. And with that, you get actually best-in-class language editing and debugging support without doing a lot of work, actually. And you only need to do your product-specific configuration on top. And beyond that, there is a rich open source ecosystem for additional requirements like modeling diagrams, DSLs, and so on, that you can just pull in wherever needed. So I really invite you to get in contact with this innovative community, and I'm sure we will find many interesting challenges to work on and solve them in a very collaborative and open manner so that everyone can benefit from these innovations. Yeah, thank you very much. So let's have a look at the questions. There is, one question here. How big part of CDT Cloud is Theia specific? Oh, that's a very nice question. Actually, there is both. There is components in CDT Cloud that are completely independent of Theia. So for instance, the CDT GDB adapter is just a plain debug adapter. Then we have VS Code extensions that can be used in VS Code or in Theia. So obviously they are not Theia dependent, but they are usable in Theia. And we have components in there that are actually Theia specific. So they are really, for instance, CDT Cloud Blueprint is a tool that demonstrates how to use Theia and CDT Cloud components in a Theia application. But it is clear that the general approach in CDT Cloud is to make the components and results that are being developed collaboratively as versatile as possible, and that often means not making them relying on Theia, because it's better to have a VS Code extension that you can use in Theia just fine, but you can also use it, for instance, in VS Code. So therefore, the choice is very often to use it using the VS Code extension API. Right. I hope that answered that question. The next question is, yesterday we heard about Theia IDE as a replacement for Theia Blueprint. Will there be a Theia IDE for C++ that will replace CDT Cloud Blueprint, similar to Eclipse for C and C++ developers? Also an excellent question. Yeah, sure, that makes a lot of sense. I can't say that there will be one in the very, very close future, but since Theia is making this step, which I think is a very important step, it just makes sense that Theia Cloud, that CDT Cloud Blueprint will follow. I think it's mainly a question of how much resources do we want to spend on this topic to gain more visibility, to gain more feedback from the users, and so on. So if you are interested in that, to join together and join forces, feel free to contact the CDT Cloud community, me and all the other ones, and discuss this topic. I'm pretty sure you will find open ears and eyes. Right, a last question. How can we get in touch with the team and the potentially amazing community support of the project? So the easiest way of doing that is by just going to the to Eclipse Dev, not GLSP, CDT Cloud. Then you will find this web page, and from there you can first of all find all the links that you need in order to download CDT Cloud Blueprint and to try it online. But in order to get in contact, you can just go to GitHub, which brings you to the umbrella project of this GitHub organization. And there, down here, you find the section Meet the people behind CDT Cloud. There is the CDT Cloud meeting page, which basically has all the details. Maybe I'll increase the size here a little bit. All the details about the upcoming meetings, how to connect, and what's the agenda for the upcoming meeting. So just feel free to drop in at any time to one of those meetings and share your ideas. And I'm sure you will be more than welcomed. And I'm sure you also will find like-minded people who have the same challenges ahead, because that's what we learned in the last couple of years where we started with CDT Cloud, is that there is independent of what exact project you're working on, if it's exactly an embedded or just C++ toolchain and so on. For one tool support, there is very often similar challenges that need to be addressed, because there is, for instance, like hardware support is just not done yet and many people need it. So I'm sure you will find a group of people who will be very knowledgeable in this area and will be glad to work with you. Excellent. With that, thank you very much for joining this session. I hope you took away some useful information. Feel free to contact us, and I'm looking forward to talking to you. Thank you. Bye.